Hey guys, welcome in. We are on our third day of notes here and examples for looking at rate of change. Today we're focusing in on rate of change from equations, being able to determine the rate of change from an equation, how we can use our tables and graphs, kind of overlapping what we've done the first couple days here and working through this. So go through some notes and examples with me, and then you'll get your assignment that you need to work on through that. So you want to make sure that you're following along with this. Start and stop the video as you need to whenever you get to certain types of questions. Okay. So first thing we want to do, right, is we want to graph the following equation by completing the table, plotting those points, and then drawing a line through the points. So we're given an equation here, right? If you look at this, we're given the equation y equals 2x. Okay. So our y value, whatever that is going to be equal to 2x. So when we're answering that question and going through those, we are trying to solve based on knowing what our x values are. And remember, when we look at our table, our x values in this vertical table are in that left column, and our y values are going to be in that right-hand column. So we're solving for y. And then once we have those points, x and y, we can plot them on our coordinate grid and create a line to represent our situation. Okay, so I have three versions of this equation, right? When I'm looking at my x values. So I need to figure out what my y is when my x is -1. I need to figure out what y is going to be equal when my x is 0. I need to figure out what y is equal to when my x is 1. So I'm going to go ahead and write out this first one. Y is equal to, right, 2 times -1. That's my first answer here, right? That I'm looking for in terms of my order pair. So my x is -1. My y is going to be equal to whatever 2 times -1 is. And so that would be -2. So I've got a point at -1, -2 on my graph right here. Okay. If I look at the second version of this equation, it's going to be when y equal, or what is y equal when my x is 0. So when I plug in a 0 for x, right? 0 is my x value. 2 times 0, my y would then be 0. Okay. So I have another point on the line here that is going to be 0, 0. Then my third part, or third set of data points here, comes when my x is equal to 1. So if I take 2 times 1, I'll get my last answer here. And my y value would be 2 times 1, which is 2. So I'm going to have a point on the graph at 1, +1, +2. Okay, so I can kind of create my line based off that, draw it going through my graph. Okay. So the next part of this, what we need to think is it says to calculate the rate of change from the table, right? And then calculate the rate of change from your graph. And what do we notice? Well, if I come over to my table here, right? Remember, rate of change is that change in y over that change in x, right? That's what we're looking for this one. Change in y over that change in x. So I'm looking at how my y values change. I'm going from -2 to +2, so that's a +2 change. From 0 to 2 is also a +2 change. So the change in my y values, if I look at the table, right, my change in y is 2 units over my change in my x values. Okay, so when I go from -1 to 0, it's a +1 change. From 0 to 1, that's also a +1 change. So I'm looking at my rate of change being 2 over 1 when I look at my table, the change in my y values over the change in my x values. If I come over here and I look at my graph, remember we can kind of make those stair steps. And I'm looking at, when I look at the change from the graph, right, I'm looking at the vertical change, or my change in y, over my horizontal change, my change in x. Well, again, if I look at this, the vertical change is 2 units over the horizontal change, which is 1. So if I'm looking at my graph, I also get a rate of change of 2 over 1. Okay, so what do I notice? I have the same rate of change for both representations. So I'm getting that same representation, excuse me there. Okay, getting that same rate of change, or that same slope, right? Remember, slope and rate of change is the same thing, whether I'm looking at a graph or looking at my table here, right? I'm getting the same value. It's 2 over 1, a vertical change or change in y of 2 over my horizontal change, right? Or my change in my x values of 1. So looking at that, we can kind of answer some of these questions as we continue to do some examples and go through this work through the rest of this. All right. So in the next part of notes, we're going to take a look at the next section. We're looking at direct variation. So when I think about direct variation, that's a specific type of example that I'm looking here, okay? Equations of the form y equals mx, okay? Mx is what we're looking at, where m represents our rate of change, okay? Which is also the same thing as saying when we're looking at our graph slope, right? Remember, these two terms are synonymous. So when I have direct variation, the equations are in the form of y equals my slope or my rate of change times my x value. So my y value is going to come from multiplying whatever that rate of change or that slope is times my x coordinate, okay? So for direct variation to happen, the graph of a line must go through that point 0, 0, and we know that to be named the origin. So this is a direct variation example because you'll notice it goes through, the line goes through that origin, right? M is your rate of change or your slope when you're calculating this and figuring that out. Remember, those two terms are the same thing. It just kind of depends on what form we're looking at. A lot of times we call rate of change when we're looking at a table or we're trying to describe it in words. But when we see that graph, right, it's the same thing as saying the slope. When we look at our slope here and calculate our vertical change over horizontal change as we go through and answer some of these questions. All right. So take a minute and just go ahead and try to graph this following equation by completing the table, plotting those points, and then drawing the line through the points, okay? So I just want you to look at this equation. If it's y equals 1/2 x, right? Remember, this is a multiplication step. And I want you to try to complete the table, graph, and plot the points. And then once you're done with that, you can unpause the video. Okay, so hopefully you pause that video and you kind of took a look at this. Remember, we've got three different representations here, right? We've got when our x is -2, when our x is 0, and our x is 2. So I'm simply plugging in those values I know, right? The x into the equation and solving for y. So for this first one, when x is -2, so y equals 1/2 times -2. When I multiply by 1/2, it's like I'm dividing by 2, right? Cutting things in half. So 1/2 times a -2 would be a -1. So I have a point at -2, -1 on my line. If my y value is 0, it'd be like saying y equals 1/2 times 0. Anything times 0 is 0. So I have a point at 0, 0, that's on the line, or the origin. And then I have a point where when my x is 2, so y equals 1/2 times 2, 2 times 1/2, or 2 divided by 2 gives me 1. So I have a point at 2, 1, okay? So my rate of change here, my rate of change as I look at this and I go through, let me pick a different color to kind of go through and look at this. I'm going to think about how's my y changing, right? So change in y over my change in x. So I can look at two things here. I can look at my table, right? I can also calculate on my graph. When I look at this here, calculate that stair-step model. My y values are going up 1 each time, right? From -1 to 0, from 0 to 1. My x values are actually going up by 2 each time. -2 to 0, and then 0 to 2. So my rate of change, my change in my y values is 1/2 when I look at the table. I also see that on my graph. It's a vertical change of 1 over a horizontal change of 2 each time. So I get 1/2 as my rate of change. So that rate of change, or my slope in this case, right? Another name for rate of change, especially when we look at the graph version of this, slope, that's going to be 1/2 for this example, okay? So I can use those values to, in the equation, right, plug in what my x values are. I can graph the equation, right? I can complete the table, plot the points, and then graph this equation that goes through those points. So if I take a look at this one, let's go ahead and do this one together. Be really careful, right? This is a multiplication step. It's a negative number. So if I have a negative x value for this first one, I'm looking at -2 times a -2, right? If I plug in these values for x, that's what's happening, right? Each one of these is going to go into that equation to solve and figure out my y value, okay? So the first one here is y equals -2 times -2. If that's the case, I end up with a y value of 4 for this one. If I plug in a 0 for x, that would be like saying -2 times 0 is what equals y. Anything times 0 is 0. And then for my last one here, if I plug in a 2 for x, it's going to be -2 times a +2. So I get y equals -4. So I've got a point at -2, +4. I've got a point at 0, 0. I've also got a point at 2, negative 4. So I'd come over here and graph that. Negative 2, positive 4 is right here. Okay, 0, 0 is through the origin. And then I've got a point at positive 2, negative 4. And so what I'll have you guys look at and kind of notice with this one, it's not perfectly straight, right? This graph looks different than the other two because of the direction it's going. My first two examples, and including the one that was in there, those were positive examples, right? Talked about looking at a positive rate of change as it grows or gets bigger, moving left to right. This is a negative example, right? So if I come back and look at my change in y over change in x here, okay, I'm going down, right? I'm going down 4. And that's over my change when I look at my x values of going up 2, right? So this one would be a negative 4 over 2 for my change. Or if I want to simplify that, right, because we don't want to have this be that, we could also say negative 2 over 1 is another way of saying this. And I can also see that when I calculate looking at my graph, right? I see a change of going down 4 and over 2 to the right, going down 4 and over 2 to the right. Or if this case, down 2 over 1, right? Down 2 over 1. I can split it up that way. Down 2 over 1, down 2 over 1. All right? So my rate of change, I could say two different ways. I could say a negative 4 over 2, or if I want to simplify that, right? I could see negative 2 over 1. These two have the same value. They're both negative examples, which makes sense because of the direction this graph is going, okay? So as you work through your examples and do some of these on your homework, what I really want you guys to focus in on is, relating to what we did with your tables to how we compare or create the graphs. Anytime you're looking for that rate of change, right, or that slope, it's another name for rate of change, right? Slope. When we look at that graph, right, we're looking at our change in our y values. So how is it changing vertically over a change in our x values, how it's changing horizontally. So if we look at the graph, if we look at our table, we can go through and do those few things. All right. So here's what you got, guys. You are working through the rest of this and answering some questions based on your assignment on your worksheet. So make sure you take your time to go through and do that. If you need to go back and check your notes, you can do that as well. All right. I know that for some of you guys, it can be a little bit easier if you kind of work through and answer the questions when you look at the examples in your notes. So make sure that you do that. All right. If you have questions, make sure that you hold on to them. We'll talk about them again more tomorrow when I'm back in class. All right. So make sure you take your time, go through these notes, fill these out, and then work on your assignment from there.